So this video is just showing you how to do normal distributions on Desmos. So you can either type in normal dist, and then if I don't put anything in the parentheses, it's going to do a standard normal, which is mean of 0, standard deviation of 1. And if I click right here and do zoom fit, I can see my curve. Okay. And so here it is. And if I can go out here, I can see every deviation. Okay. So I can see going out 1 standard deviation, 2 standard deviations, 3, and so forth in both directions. Now, if I wanted to find a particular percentage, okay, this is going from negative infinity to infinity, showing the area underneath it as 1. Let's say that I went from 0 to, well, let me do this. Let me go from -1 to 1. And so if I'm going from -1 to 1, you see that this is the 68%. That is 1 standard deviation. If I'm going from -2 to 2, you see I get the 95% of the data. And if I'm going from -3 to 3, you're going to see that I'm going to get the 99%, okay, 99.7% of the data. Now, this was if it is a standard normal curve. Now, I can also do this if it is not a standard normal curve. I put the mean in. So we had the one from our notes was a mean of 15 for the showers and a standard deviation of 3. And then if I click this, I'll see that. Okay, so my mean here is at 15. Okay, so let me just kind of zoom out going by 5s. So my mean is at 15. And then if I go out every 3, okay, that's going to be a standard deviation. Okay, and so that is a picture of that. Now, if I want to find a particular percent, like we wanted to figure out what is the probability that they are between 13 and 17 minutes long. I can go 13 to 17 and I get 49.5, which was the answer that we got when we did this problem. Okay. And actually it wasn't standard deviation of 3. We had a standard deviation of 2. Let me correct that. And we ended up getting a 68. Okay, we ended up getting a 68.26. Okay, so it was a mean of 15 and standard deviation of 2. The second question from our notes, we wanted to know that it was either less than 12 or greater than 21. So less than 12, if I get off of this and click, here's my negative infinity, and then I need 12, not, I need a 12, not 100. And I see that I get this much. Okay. And so I'm going to copy that. Sorry, I didn't want to copy that. I wanted to just copy this here. So I'm going to be taking this and I'm going to be adding it on to the amount that I get when instead, if I want to go from 21 on, okay, let me click off of this, get rid of this, and then click off and give it to me as infinity. I get this amount, so let me highlight that, put that here, and then I get my 0.068, which is what I did get. If I move this for a second, I had that right there on letter C. Okay. Now, if I want to do the next question, I want to see when it's between 11 and 18 minutes long. Okay. So I put in an 11 and 18 and I get this percent. Now, in this problem, we had 70 people. So I'm going to take 70 times, and let me just copy this and put them here. And I end up, sorry, I don't want that. Let me get rid of that. I end up with 63.73 people. And if I move that, we got 63.7 people. So we got the same answer. Now, the bottom one here, we were dealing with this one with a mean of 500 and a standard deviation of 100. So let me just set that one up. Okay, so let me have a mean of 500 and a standard deviation of 100. And we wanted to see what it was if we scored a 585. So basically, I want to go from negative infinity to 585 and see what percent, because we want to be in the top 70%. And so we have 80% of the people below us. Okay, so that was what we got on this problem here. Okay, we got the 80.23. Now the next one, we want to know what value z-score do we need, okay, for a standard deviation, to get 70%. So what I'm going to do, okay, click off of this. I am going to type in normal distribution, okay, and it's the 500 to 100 in terms of our mean and our standard deviation. Put a point, and then I'm going to do inverse CDF, and we want 70%, so I'm going to put 0.7, and it gives me the score, 55.2. And that is the score that I had here, 55.24. Now, I've been typing in normal distribution and inverse norm, but let me get rid of these for a sec. Instead, if I come to the wrench, okay, if I come to the wrench, let me just kind of zoom out. Not come to the wrench, but I come to down here. Let me just pause this for a second. So if I come down here to this show keypad and I come to functions and you scroll here under distributions, you see normal distribution. So it's there if you want. And if I hit this zoom fit, it'll fit it to the screen. And again, here, if I want to find a particular percent, and this is with a standard normal curve with a mean of 0 and a standard deviation of 1, I can, for example, go from negative infinity up to 1. And it's going to show me that that would be 84%. Okay, would be this whole thing here. Or maybe I want to go from 1 to infinity. So let me just get rid of this. Click off. And this portion here is going to be 15.86%. Or maybe I want to go from 1 to 2, something like this. And I see that that's going to be 13.59% is this. If my mean is not 0, I can always put a different number in here. So let's say my mean is 20 and my standard deviation is 2. Okay, and I click this, it's going to show me what that would look like. And then if I wanted to see, well, what's the probability of being from, let's say, 13 to 24, it would show me that from 13 to 24, that's going to be 97.77%. If I wanted to do an inverse norm, I can come here, come to functions, okay, get my normal distribution, And let's say what it is. So let's say it wasn't a normal one. Let's say it's 20 to 2. Put a point, and then I can click here again and pick my inverse. Whoops. My inverse CDF. And let's say I wanted to know what's the top. Well, let's say I wanted to know 85%. I want to show 85%. So this would be 85% of this would be at 22. So if I came up here, I could double check it. Okay, I'm going to get rid of that, go from negative infinity up to, and I'm going to put this number in. So let me just copy this. And paste it here. You see that I get the 85%, which is what I was looking for. So you can always do this on Desmos also.